Good morning, and today we'll be talking about single replacement reactions. So a single replacement reaction is a reaction where one chemical entity replaces another chemical entity which is previously bonded to a third chemical entity. In order to correctly solve these problems, you have to be very comfortable with the activity series for metals and the activity series for nonmetals, which is right here. So when posting this assignment, I included a handout which ranked metals from most reactive on the top to least reactive on the bottom. Here, due to space issues, instead of listing the most reactive metal on the top, I listed it on the right top area of this list, and I listed the least reactive metal on the bottom right, and this was top left. So top left is most reactive, and bottom right is least reactive. So knowing that, you have to ask yourself the question, will this metal replace this metal? So to answer that question, you have to look at the activity series and see if Ag is above or below, or if Ag is more or less reactive than potassium. Potassium is the second most reactive metal. Ag is not more reactive than potassium. Therefore, this reaction will not occur. You can simply write NR. So this would be the correct answer for this practice problem. So single replacement reactions will only occur when a more reactive metal or nonmetal replaces a less reactive metal or nonmetal. Is Ag more reactive than K? If the answer is no, your outcome is no reaction, or NR. So let's look at the next problem. Here we have zinc reacting with silver bound to nitrate, which is silver nitrate. Will this reaction occur? So we have to look at the activity series. We're asking ourselves if zinc is more reactive than silver. Indeed, zinc is more reactive than silver. It is located above silver on the traditional activity series, which I posted in Google Classroom. And on this reproduced activity series redux, it is to the left and above Ag. Therefore, this reaction will occur. The zinc will react with the nitrate ions, and this is the correct stoichiometric balancing for this reaction. So please take note of this. Moving on to the next problem. Again, this is a single replacement reaction because we have a lone chemical entity reacting with a bonded chemical entity. But here, we're dealing with fluorine, which is a nonmetal, which might or may not replace iodine. How do we know? Well, we have to look at the activity series for nonmetals, which is right here. So most reactive nonmetal is on the right. Sorry, on the left or top. In this case, it's just a single line. So F is the most reactive. Fluorine is the most reactive metal, nonmetal, followed by chlorine, followed by Br, followed by I. So I can perhaps rank these according to reactivity in this manner. Okay, so the most reactive nonmetal species is on the left. The least reactive nonmetal species is on the right. All right, so here is F reactive enough to replace I. You're comparing F and I. Iodine is the least reactive nonmetal. So of course, it can be replaced by the most reactive nonmetal. So this reaction will take place. The fluorine will now react with potassium to form potassium fluoride. The iodine will be singly replaced. So this will be the correct stoichiometric balancing of this reaction. So moving on, this is another example. Here we have copper, which is a metal, and is going to react with iron to sulfate. Iron is also a metal, so here we have to ask ourselves, is copper more or less reactive than iron? So iron is here on the activity series, copper is here. The activity series is ranked from most reactive on the top left to least reactive on the bottom right. So in this case, lithium is the most reactive. Iron is somewhat reactive, but copper is not very reactive. So iron will replace the copper. But in this case, will copper replace the iron? No, it will not. So the converse doesn't work here. Copper will not replace the iron. You have no reaction. Going on to the next problem. Okay, here we have, will iron replace the lead? Okay, so iron is here on the activity series. On top left. So, and where is our lead? Lead is lower on the activity series. So yes, iron is reactive enough to replace lead. So this would be the outcome of the reaction, and this would be the balanced reaction. So now we're dealing with comparing copper and aluminum. So most reactive chemical species for metals is in the top left. So aluminum is here, copper is here. Aluminum is more reactive than copper, therefore copper will not be powerful enough to replace aluminum because copper is less reactive than aluminum because it's further to the bottom right. Therefore, this will be your answer. No reaction for number 6. So now we're going to number 7, which is the last problem. So we have to, once again, most reactive top left, least reactive bottom right. So here, if aluminum is more reactive than lead, will this reaction take place? Absolutely. Why? Because aluminum can replace lead here. And once you use stoichiometry to balance the coefficients, you have this answer. If you want some more detailed explanation, I'll be happy to explain if you reach out to me via email. But since we already know stoichiometry, this would be the final answer, and this is the application of the activity series for this problem. You always want to compare for single replacement reactions the chemical entity that's by itself to a chemical entity of a similar kind. In this case, you're comparing two metals, aluminum and lead. And you're always comparing the non-bonded metal to a bonded metal, or a non-bonded non-metal to a non-bonded non-metal to a bonded non-metal, which was the case with the problem number 4 here. We were comparing, oh no, problem number 3, where we were comparing two nonmetals, fluorine and iodine. We're always comparing something that's by itself with something that's bonded. The comparison has to be between two metals or two nonmetals using the activity series for nonmetals or metals. So at this point, if anyone has any questions, please reach out to me via email, and please attend the general Zoom meeting to earn extra credit and to clarify any areas where you might still need further explanations. Thank you and have a good rest of the week.